Dilutions II. This is 8.2b in your book, and I don't know what page because I don't have my book with me. So what we're going to be doing today is this is the technique we use to prepare a dilute solution from a more concentrated stock solution. That's what we call the concentrated solution, is a stock solution. So to prepare a dilute solution from a more concentrated stock solution. So the first thing you're going to be doing is you're going to, number one, guess what? Find the, you're right, moles of solute that you need in the diluted solution. And then you're going to say, okay, well, I want that many moles in this diluted solution. What volume of that concentrated solution contains that many moles? So you're going to figure out what volume of the concentrated solution of the concentrated stock solution contains that many moles. Okay, so let's do a very straightforward example, again with these kind of little dot things. So for example, I want to make 2 liters of concentration of our dot equal to 2 molar, and I'm starting with a stock solution of concentration of the dots equal to 8 molar. Okay, so how much stock solution are we going to need? How much stock solution will we need? How much stock solution will we need? Now, first of all, how much? When we're looking at how much of a solution, obviously, I hope it's obviously, we will be looking for the number of liters. Why did I write question mark and number? I don't know. That's okay. Oh, and it's not erasing. Some days all it will do is erase, and today it's not erasing. Oh well, that's okay. Oh, there we go. All right. So let's start with the solution that we want to make. This is what we want to make. Well, I want to make 2 liters of 2 molar dots. So I want 2 liters. There's 1 liter. There's 2 liters. Okay, so altogether we have 2 liters of 2 moles per liter. So if that's 2 liters, then this is 1 liter, and I want it to be 2 moles per liter. So that's going to be 2 moles in this liter. And I'll also have my other liter of solution, which is also 2 moles per liter. So there's going to be 2 moles in that liter. So in order to have 2 molar solution in 2 liters, we're actually going to need 4 moles of our dots. So we could calculate that. So the moles of dots required is equal to, well, we have 2 liters and we need 2 moles of dots per liter, which gives us 4 moles of dots. So we found the moles. That's step 1. Step 2, how much 8 molar stock solution will you need to get those 4 moles of dots? Okay, so let's take a look. Let's say we had 1 liter. Okay, there's 1 liter. And I know that I have a concentration, this is my stock solution here. I know that I have a concentration of 8 moles per liter. So I know that within that 1 liter there are 8 moles. So 1, 2, 3, 4, 5, 6, 7, 8. So the question then becomes, how much of this solution do I need to get 4 dots? Well, if I cut this in half, look, I've got 4 dots. Well, what volume is this? This is a half a liter, right? So I would need a half a liter of that 8 molar stock solution. So I would take a half a liter. I would take that half liter of stock. Yes, and it would fill up this portion of my beaker. And it would have 4 moles in it. And this right here is a half a mole, a half a liter. And then I would fill up the rest of it with another 1, 2, 3 liters. So this area here would be the extra 3 liters of water. But probably I wouldn't do that. Probably I wouldn't just add 3 liters of water. Probably what I would do is I would find a 4 liter, or sorry, not a 4 liter mark. I would find a 2 liter mark. Oh my God, what's wrong with me? I'm not adding 3 liters of water. I'm adding 3 halves. 3 times a half. So that's 1 half, 2 halves, 3 halves. Okay, so that's 3 halves liters of water, and I would add those half liters. But probably what I would do is I would just say, okay, there's my 2 liter mark on my container, and I would then fill it up to the 2 liter mark. All right, now I'm not going to be drawing these pictures every time because that's just crazy talk. So for step 2, instead of doing that, what I would do is for step number 2, I would calculate how many liters of stock solution do I want? Well, I need to contain 4 moles, and I know that my stock solution, I need to cancel moles and find liters. I know that it is 8 moles per liter, which gives me 0.5 liters, or a half a liter. Okay, and so that is how we would do our calculations. Now, how would I do this in practice? Well, what I would do is let's see, not that one, that one. Okay, so this is written out in a much more tidy form in your book. And this is also in your book. And it shows the procedure for making a diluted solution, which is a lot like the procedure for making a solution without it being a dilution, except for instead of adding a solid to the volumetric flask, you are going to take some of the stock solution. Okay, so you'll take some of the stock solution and you are going to fill the pipette to the mark, okay, of whatever volume it is you need. And if it's too big for a volumetric pipette, maybe you will use a graduated cylinder instead, but that's okay. For this one, we're going to use a pipette, and we're going to take that stock solution and we're going to add it into a volumetric flask of the correct size. And then we are going to add water, add water, add water, add water, keep adding water, keep adding water, adding water, adding water until we get to the mark. Okay. Now you can see the color of this. Oh, this was the original one. This was the original. Sorry. This is the stock. I misinterpreted that. So we have our little bit of stock solution now at the bottom of our second volumetric flask, and we fill it up to the mark. And you can see it's a lot lighter in color because it's now more diluted. Of course, when you get close to that calibration mark, you are going to use a wash bottle, okay, just like we did in the other solution making procedure. And then when you get very close, you are going to use the eyedropper, okay? And that's because if you go past the calibration line, you have to start all over, and that would suck. And then finally, your volumetric flask, just like before, you should stopper it, and then you're going to invert it. It's going to be turned upside down and right side up a few times to ensure thorough mixing. Special consideration. This is for acids. Do as you oughter. Add acid to water. Okay? And this is because when you are diluting an acid, it's actually the mixing of an acid and a water is a very exothermic process. So a ton of heat is released. In fact, so much heat is released that it can make a lot of steam, and that steam can bubble, and it can end up splashing in your face. And that is a very, very sad thing. So if you have lots of acid and it's really concentrated, especially if it's dilute, then it doesn't matter too much. But if you have a very concentrated acid, if you have the acid first, right? So if you have your acid and then you add to it the water, it doesn't actually go boom, but you would have like spattering because it's so exothermic, okay? And reactions are quicker and produce more heat in a shorter amount of time the more concentrated things are. So this is a very concentrated acid. So in order to make that not a problem, what you'll do is instead of when you're diluting an acid, you'll put some water in first. And then you'll add slowly your concentrated acid. Okay, and you'll stir it. And it's going to then disperse. And then finally, once you have done that, after you've added the acid, it will get warm, but it won't go like, spattery boiling acid water all over the place. So you have water, add your concentrated acid, and then you will add water to the final line. Okay? Now, there's a bunch of questions here, but we are going to do another example. Where did it go? There we go. So this is an example that I did last term, and in last term I was actually trying to make, I was trying to refill one of those carboys. You know, the ones that we had in our titration experiment, right? Where we went and got our acid and base, we had a little valve there, and there was a tap, and the liquid came out of it, and on the top there was like a screw-on lid kind of thing. Yes. And they fill up to about 12 liters. Okay. And we are almost out of one of the solutions. Let's say that last semester, we were almost out of the NaOH. All right. And I went into the back storeroom, the laboratory prep room, and on a shelf, this is a shelving unit. I know it doesn't look like a shelving unit. It looks like every other beaker I've done, but it's actually a ginormous shelving unit. I found a bottle of 2 molar NaOH. Now that's a smallish bottle. You can imagine it's like a half a liter bottle, size of a water bottle, okay, of 2 molar NaOH. Now in our experiment, in our acid-base experiment, I wanted 1 molar. Not 1 molar. I wanted approximately 0.10 molar NaOH. All right. And I wanted 12 liters of it because I wanted to be able to use it for an entire class, and not just your class, but other people's classes as well. Ms. Wu and Ms. Weinberg were also doing this experiment. So I wanted lots and lots of this 0.1 molar NaOH. But what I had was some 2 molar NaOH. So I needed to figure out how much of this do I need to make 12 liters of the 0.1 molar NaOH. Okay, well, step number 1, find your moles. Find moles of NaOH. Okay, and so I know I have 2 molar. I know I have 2.0 moles of NaOH per liter. Oh, that's not where I'm going with this. That's my stock. But I also know that my diluted NaOH is going to be 0.10 moles of NaOH per liter. And I know that I want to have 12 liters of it. So I say, which molarity am I going to use to find how much I need? Well, this is how much I need. So I'm going to use that to find my moles. So the moles of NaOH needed is equal to 12.0 liters times 0.10 moles of NaOH per liter, and that gives me 1.2 liters, 1.20 liters. I'm playing really fast and loose with my sig figs here because I know I've got only 2 there, but that's okay, whatever. We're not going to worry about it too much right this second. And now that's how much I need. Oh, why did I write liters? That's not liters, that's moles. So I haven't really had a cup of coffee yet this morning, and my brain is like, woo! So that's how many moles of NaOH we need. Now, I want to get that amount of moles out of this stock solution. So I'm going to say, how many liters of sorry, not 0.2, of 2 molar NaOH will give me 1.20 moles of NaOH. You need to cancel moles of NaOH and find liters of NaOH. So we have 2 moles, right? Our 2 moles of NaOH per 1 liter. And 1.2 divided by 2 is 0.60. And my unit will be liters of NaOH. So find the moles needed. And then calculate the volume of your stock solution. Stock solution. Now, could we do this using that formula that we had yesterday, where we had our new concentration is equal to our old concentration times our dilution factor, which is the old volume over the new volume. We could, because we are actually, at this point, we are trying to find not the new volume, we want to find the old volume, because we're wanting to find the volume of the stock solution. So you can solve this. You can say my new concentration times, I'm going to bring my new volume up here, times my new volume And then I'm going to bring my old concentration down to the bottom over my old concentration is equal to my old volume. I don't think this saves you any time, quite frankly, but you can do it this way if you want to. So my old volume is equal to my new concentration, which is, my new concentration is 0.1 molar. 0.10 molar. And my new volume is 12 liters. And then I'm going to divide that by the old concentration, which is, it was 2 molar. Well, if we look at our units here, molarity cancels out, and I am left with volume, and I will end up with 0.60 liters. Now, probably I'm going to measure this as 600 milliliters because I can go and find myself a 1,000 milliliter graduated cylinder, right? Which is 1 liter. It's a 1 liter graduated cylinder. And I will fill that up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 600 mils of my stock. Okay, and then I will go take that 600 mils and I will dump it into the carboy. So I have 600 mils of the stock solution in the carboy, and then I will fill that up through the top with water all the way up to the 12 liter mark. Okay? And that is it for that. So give those questions a try. Should I teach you the other way? Yeah, I'm going to. So if you are interested in learning the third way of doing this, the key to all these dilution problems is that moles before the reaction, not reaction, before dilution, is equal to the moles after the dilution. And we can calculate moles because we know that volume times molarity, moles per liter, is equal to moles. Yes, because we have volume, liters, times moles per liter is equal to moles. And over on our other side, we would have the volume times the moles per liter is equal to the moles, and the moles before are equal to the moles after. So if we call this, these liters, if we call those liters volume 1, times molarity 1, that equals our moles. That's going to be equal to volume 2 times molarity 2. And this gives us a lovely formula. And normally, and I don't know why exactly, people usually write this as either M1V1 equals M2V2. I don't know why the V doesn't go first, but usually that's how it's done. And more common than this even is C1V1 equals C2V2. What do you think C stands for? C stands for concentration. Okay, so let's do a question like this, and this will work for all of the dilutions 1 questions and all of the dilution 2 questions. All right, and so let's try an example using this particular formula. I want 200.0 milliliters of 0.4 molar HCl. I have a stock solution of 6 molar HCl. How can I make the 0.4 molar HCl? Okay, so I'm going to try using this new formula, C1 V1 equals C2 V2. And what I'm going to do is I'm going to say I need to connect things to each other. I need to connect my volumes. And so I say, oh, 200 milliliters is connected to 0.4 molar. So let's call this one V1, and let's call this C1. Okay? Now I also know that I have 6 molar HCl, but there's no volume associated with that. So this is going to be my second concentration, C2. Okay? Now I don't know my volume of the stock solution that I need. So the volume 2 is the volume of the HCl, which is at 6 molar. I don't know what that volume is. So let's solve our equation for V2. This is our unknown. So V2 is equal to C1 V1. See, I've flipped the equation around. I've put V2 over on the left. It was on the right. I've moved these two guys over to the other side. And now because I would have C2 here, but I don't really want it there, I'm going to move it to the other side. And when I do that, I'm going to bring it down to the basement. That's straightforward algebra. Let me know if you have any issues with that. We can go over it in more detail after the break. So C1 is 0.4 molar. 0.4 molar. V1, 200 milliliters. C2, 6 molar. Okay, and we get molar cancels out. Okay, and I end up with, oh, sorry, I've got to grab myself a calculator here. This might be more challenging than I thought. Sorry, this will take a second. I need 0.4 times 200 divided by 6. And we get 133.333, etc. milliliters. Now, if I was doing this to sig figs, well, let's make that 0.40 so it's not too stupid. And I would say 130 milliliters. But because I'm making a dilution, and I would like this to be as accurate as possible, I could probably, in actual fact, I would probably measure out 133.3 milliliters because my measuring device probably can at least measure out 1 milliliter increments. So in actual fact, maybe not 0.1. We'll take a look at it when we get back to school. Okay, I will probably measure out 133 milliliters. This is like when you calculate your mass to make a solution and you're like, oh, I only can go to 2 sig figs, so that's 20 grams. But in actual fact, it was like 19.5 grams was the amount you calculated, and your balance can actually weigh to 2 decimal places, so you would try and weigh out 19.50 grams on your balance. Similarly, you're going to try and be as specific as you can with the measuring tools available. So I'm probably going to measure out 133 milliliters. I want, what did I want? 200 milliliters. So I am going to go get myself a volumetric flask. And it's going to be a 200. This sounds like a really wrong number. 0.4. It is. It should be 13.3. I'm so sorry. 13.333 milliliters, which we're going to measure as 13.3 milliliters. Now, it would make a lot of sense for us to just stick our 13.3 milliliters of our 6 molar HCl into our flask. However, HCl is an acid. So, do as you order, add acid to water. So we're going to fill this maybe halfway full with water. Slowly, we're going to add our 13.3 milliliters of the 6 molar stock solution. Slowly add 13.3 milliliters of the 6 molar HCl. We're going to swirl it gently. And then we are going to gradually add water to the 200 milliliter calibration line. That was not the best lesson ever, but it's what you're going to get when I start teaching at 6:45 in the morning. So, at any rate, that's Dilutions II, and I will see you after spring break. Have a great holiday. Bye.